Today in this video I'm going to discuss few NCERT questions of chapter number 3, motion in a straight line. So the first question is, woman starts from her home at 9 am, walks with speed of 5 km per hour on a straight road up to her office 2.5 km away, stays at the office up to 5 pm and returns home by an auto with speed of 25 km per hour. Choose suitable scales and plot xt graph. Xt graph means distance time graph of her motion. Now at 9 o'clock she's at home. Okay, now if you see the distance time graph, at 9 o'clock she's at home, so it is at the origin of the graph. So speed is 5 km per hour, distance from home to office is 2.5. You find the time and you get 0.5 hour, that is 30 minutes. So at home she was at 9 am, she starts at 9 am, so she would reach office by 9:30. You see the graph, at 9:30 she's at office. The distance is, so at 9:30 the position would be here. Now she stays at office up to 5 pm. So till 5 pm we'll draw a straight line because position is not changing, she is in office only. Now while returning, the speed while returning is 25 km per hour, distance remains the same. So you find the time by distance divided by speed, 2.5 divided by 25, that is 1 by 10 or 0.1 hour or 6 minutes. So at 5 pm she left office, so she would be back at home at 5.06. So at 5.06 you will draw a line till 5.06, that means she is at home, and this is the xt graph of this question. A very good reasoning question. A drunkard walking in a narrow lane takes 5 steps forward and 3 steps backward, followed by 5 steps forward and 3 steps backward. Each step is 1 meter long and requires 1 second. Plot the xt graph of his motion. Determine graphically and otherwise how long the drunkard takes to fall in a pit 13 meter away from the start. So he is moving in a very strange pattern, that he takes 5 steps forward and 3 steps backward. So time taken to move first 5 meter would be 5 seconds because each step is of 1 meter, and time taken for each step is 1 second. So time taken to move first 5 meter would be 5 seconds. Time taken to move 3 meter backward would be 3 seconds. So 5 meter forward, 3 meter backward, the net distance covered would be 2 meter and the time taken would be 8 seconds. So in 8 seconds he is moving only 2 meters. So if we taking 2 meters in 8 seconds, then he would be covering 4 meter in 16 seconds, 6 meter in 24 seconds, 8 meter in 32 seconds. Now when he has covered 8 meter, now his pattern is to go 5 meter or 5 steps forward. So when he takes 5 steps forward, that is 8 plus 5, he would fall in a pit which was 13 meter away from him. So till 8 meter 32 seconds and then 5 steps forward, that means 32 plus 5, 37 seconds. So he would be taking 37 seconds to fall in a pit 13 meter away from the start. Now this is the xt graph. If you see, 5 step forward, 3 step backward, so you are going downwards. So he's at 2 meter, then 5 step forward, 3 step backward, 5 step forward, 3 step backward, again backward, and then 5 step forward, and you are at 13 meter pit. This is the xt graph of this question. So either you can find it graphically also, or either by unitary methods. This is the answer. 37 seconds he would take to fall in a pit. The next question is, a car moving along a straight highway with a speed of 126 km per hour is brought to stop. So initially is 126 and final is 0 within distance of 200 meter, that is s is equal to 200 meter. What is retardation, that is a, and how long does it take for the car to stop, that is time. So the initial is 126 km per hour, that you will convert in meter per second. So it becomes 35 meter per second. Final speed is 0. So v is 0. Distance covered is 200 meter. So you will be applying the third equation of motion, that is v square minus u square equal to 2as. So 0 square, when you put the value, you find the value of acceleration, that is minus 3.06. Minus sign shows that it is retardation. Now for finding time, you can use the first equation of motion, that is v is equal to u plus at, then t is equal to v minus u by a. Then you substitute all the values, you get the answer 11.44 seconds.